Alright, so 1.6 for chapter 1 electricity is a combination of capacitor which is in series and parallel circuit. Alright, so at the end of this topic, students should be able to deduce and use the effective capacitance of capacitors in series and also parallel circuit. Okay, so first we look into the capacitor in a series circuit. So for the first set, you need to know is how actually the series circuit. So the capacitor in a series circuit is connected side by side. As example, we can look into this diagram. So C1 and C2 is connected side by side, and C2 and C3 also is connected, alright, side by side. Alright, so the thing that you need to know is for this series circuit capacitor in series circuit is Q is actually same for every capacitor. So Q total is also same with the Q at C1 and also same for Q at C2, and also same with the Q3 at C3. So Q is a charge, sorry. Alright, so the other thing that you need to know is for the potential. So potential for capacitor in series, it should be different. So V potential total is equals to V1, which is potential at C1, plus at V2, which is potential at Q2 or C2, plus with the V3, which is potential at C3. So this is the thing that you need to know. Alright, so for when you know this kind of theory, and then you can know how to calculate the sieve effective. Alright, so how we gonna find out the effective capacitance is, okay, so for V total, for Q total is equals to C effective times by V total, potential total. Alright, so we want to find the C effective. So V total is equals to Q total over C effective. So by equation of voltage, we can have V total is equals to V1 plus V2 plus V3, which is V1 is at potential at the capacitor 1, and V2 is a potential at the capacitor 2, and V3 is a potential at the capacitor 3. Alright, so what we can have here is, we have no write this, so V1 forgot already. So V1, oh sorry, okay. So V1 is equals to V1 is equals to Q1 and C1, and we know V2 is Q2 and C2, and V3 is Q3 and C3. Alright, so from this question kita boleh masuk, we can substitute into this question. Alright, so VT is QT, C effective equals to V1 is Q1 over C1 plus with the Q2 C2 plus with the Q3 and divided by C3. Right, so what we can have here is, we know that the theory is charge is same for every capacitor that is connected into the with the series circuit, right? So we can cancel Q. So it means that Q total is equals to Q1 equals to Q2 and also equals to Q3. So we can cancel it. So what we have here is 1 over C effective is equals to 1 over C1 plus 1 over C2 and plus with the 1 over C3. So right now we have the formula for C effective for series circuit. Yes, right. So this one is the basic formula for series circuit to find the C effective capacitance, effective capacitance. Okay. Alright, so next is a parallel circuit. So capacitor that is connected in parallel. So what we have here is the diagram of the circuit. So this is a point and point, let's say is point A, and this one is point B. So the capacitor is connected by parallel. As we can see, the points that is connected is same for C1, C2 and also C3. So this one is parallel, C1 is parallel to C2 and also parallel to the C3. Alright, so the thing that you need to know for this parallel circuit is Q total is not same as before as the series. So Q total is equals to Q1 is a Q1 charge at the C1 plus with the Q2, which is this one is Q1, and Q2 is the charge at the C2 and plus with the Q3, which is charged at the capacitor 3. Okay, so for voltage, right, so the for voltage V potential ataupun voltage potential total is equivalent to every capacitor that is connected in parallel. So let's say we have here V potential total is equals to the V1, which is potential at C1, and then plus not equal with the V2, which is potential at capacitor 2, and equals with the V3, which is potential at the C3, right? Okay, so you need to know here this one is the basic knowledge about capacitor in the parallel circuit. Alright, so next is the charge stored by each capacitor C1, C2, C3, Cn are Q1, Q2, Q3, Q1, Qn respectively. So Q1, so we have here Q1 is equals to C1 and V1, and then we have here Q2 is equal to C2, V2, and Q3 equals to C3 and V3. Right, so a capacitor with the equivalent capacitance CE will hold the same total charge when connected to the battery. Right, so you need to find the effective capacitance. So how we're gonna find it is, okay, first you need to know the basic things that I have been told you is charge for parallel is not the same. Okay, charge for capacitance connected in parallel is not same. So Q total is equals to Q1 plus Q2 and plus Q3. Right, and then V potential, V total is equals to V1 equals to V2 and equals to V3. Alright, so how we gonna find out the effective capacitance is so because of Qt is equals to Q1 plus Q2 plus Q3, so we use that kind of formula, Q1 plus Q2 plus Q3, because of we have know that QP is equals to C effective times V total, and then we know that Q2 is equals to C2 V2, and we know that Q1 is equals to C1 V1, and we know that Q3 is equal to C3 and V3. So let's substitute it. So C effective is times V total equals to Q1 is C1 V1 plus C2 V2 plus C3 V3. Okay, so what we have here, we know that VT is equals to V1 is equals to V2 and also equals to the V3, so we can divide it. Right, so we can get the last question, which is C effective equals to C1 plus C2 plus C3. So this one is the formula how to find the effective capacitance in parallel. Okay, C effective in parallel circuit. Okay, alright, so let's do the example. So what is the total capacitance in A, B and also C? So this A and this B and this one is C. So let's go. Alright, so for the question A, first thing is you need, when the question like this, first thing that you need to do is look into the circuit. Is it the parallel or series, or is it the capacitor is connected in parallel or series? Alright, so for question A, we know that capacitor is connected in parallel. Alright, so basic things for parallel, kita tahu the formula is C effective is equals to C1 plus C2 plus C3 plus dot 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 plus Cn. Okay, so for this we have C1, C2 and C3. So C effective is equal to C1 plus C2 and plus C3. So we know C1 is 5 microfarad and C2 is 10 microfarad and C3 is 15 microfarad. So just substitute it. So C1 is 5 microfarad plus with C2 is 10 microfarad plus with the 15 microfarad for C3. So what we have here, add on together and you can get 30 microfarad. Wow, fantastic, fantastic. Alright, get it? Alright, so the next question is question B. Alright, so I have been said that first thing that you need to do is look into the circuit. Is it parallel circuit or series circuit? Okay, so this circuit we know that there is a series. Oh my god, series circuit. So series circuit, the formula is 1 over CE is equals to 1 over C1 plus 1 over C2 plus over C3 plus dot 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 plus 1 over Cn. Right? So for this question we have 3 circuit. So C1, C2 and C3. 1 over CE is equals to 1 over C1 plus 1 over C2 plus 1 over C3. So just substitute it. So 1 over C1 5 microfarad plus 1 over C2 is 10 microfarad plus with the C3 is 15 microfarad. Okay, So just add on, and then you can get 2.72 microfarad. Oh my god. CE is equals to 2.72 microfarad. Alright. So next question is question C. Sorry, terbatuk-batuk lah, sorry. Alright, so the question C. Question C. Okay, so look into the circuit. So from the circuit we know that this is a combination of series and parallel. It's not difficult but a bit higher level from previous question. Okay, so C1 and C2 is connected in parallel. So C1 C2 to the C3 is connected by the series. Right, so how are we gonna solve it? Okay, first for this question we need to solve the parallel first. Okay, we solve the parallel first. Alright, so C1 and C2 is parallel, so we solve the C1 and C2. So C12 is equals to C1 plus with the C2. So C12 is equals to, substitute, C1 is 5 microfarad plus with the C2 is 10 microfarad. Right, so 5 microfarad plus with the 10 microfarad you get, of course, 15 microfarad. And then we can see here, and then after we solve for C1 and C2, what we have been done is we simplify the circuit. So right now C12 and C3 is a series circuit. Okay, so right now we can find the effective capacitance. Yes, we can find it. So C effective, which is you can find by using series formula. So 1 over C effective is equals to 1 over C12 plus with the 1 over C3. So substitute it, 1 over CE over C12, which is C12 is 15 microfarad plus with the 1 over C3 is a 15 microfarad. Alright, so CE is equals to, so you tekan calculator, you tekan and then you get the 7.5 microfarad. Wow, fantastic. Right, so actually the question is very simple. Okay. Sorry. Alright, so back to the PowerPoint. Okay, so done. Oh my god. So next example, which is find the potential difference across the capacitor, which is X and Y and also Z. And we have another question, find the charge reside on the capacitor X, Y and Z. So this is a circuit. So we have battery here, we have a battery here, our power supply which is 12 volt, and we have CX here which is 6 microfarad. We have CY 1 microfarad, CZ is 2 microfarad, and then this is a combination of series and parallel. Oh my god, series and parallel. So don't worry, this question we can solve it, right? So let's go. Okay, so this question, so first is you need to find, so when we get this question, what you need to do first is look into the circuit. So CY and CZ is a parallel, and CX to the CY and Z is a series. So we find the C effective first. Sorry. So CY Z is equals to CY plus CZ. So CY is 1 microfarad plus CZ is 2 microfarad. So you get 3 microfarad. Oh my god. And then so when we done for CYZ, actually we have simplified the circuit. Oh my god. So the circuit will be like this. So sini is CX and this one is CYZ. Like that. So CX and CYZ is a series. So this one is series. Okay, so we can find the C effective. So 1 over CE effective is equals to 1 over CX plus 1 over CYZ. Okay, so let's substitute it. So CX is 6 microfarad and CYZ is 3 microfarad. And then tekan calculator and then you can get the you can get 2 microfarad. Oh no, not yet. 1 over 2 microfarad and then change it to that to on top and then you get the C effective is equals to 2 microfarad. Okay, so right now we have simplified the circuit. So the capacitor become 1, which is C effective here. Like that. Alright, so you have been found the C effective. So the question asks you to find what? Find the potential difference. So you need to find V for every capacitance. Oh my god. Okay, so first thing first is you need to find the Q total, charge total. Sorry. So Q total is equals to C effective times by V total. So right now we have known the C effective is equals to 2 microfarad and also we know that total potential is 12 volt. So V total is equals to 12 volt. So just substitute it to find the charge total. So C effective 2 microfarad times with the 12 volt and then you can get 2.4 times 10 to the power negative 5 coulomb. So right now we have the charge total which is 2.4 times 10 to the power negative 5 coulomb. So apa lagi? Carilah. So for Vx, okay, kita tengok. So we look into the Cx first. This one. So the diagram like this. Oh sorry. Oh my god. So this one is Cx and this one is CYZ. Right? So we want to find the Vx. Okay. So how we're gonna find it is we know that Qx is equals to Cx and Vx times by Vx. Alright, so Qx because of Cx, CYZ is connected in series, so it means that Qx and QYZ is same with the Q total. So it means that sorry, Qx is equal to the QYZ and also equals to the QT pi. Okay, QT pi is you, but me is handsome. Alright, so Qx is equals to QYZ and also equals to QT. So we have been know Cx is 6 microfarad. So we can find the Vx. So Qx divided by Cx. So Qx is a 2.4, which is same with the Q total, times 10 to the power negative 5 coulomb divided by Cx. Cx is 6 microfarad. So we can get Vx is equals to 4 volt. So Vx we can get 4 volt. Okay, so Vx 4 volt. So Cx is 6 microfarad and Qs is equals to 2.4 times 10 to the power negative 5 coulomb. So right now for capacitance X is done. So the remaining is capacitance Y and capacitance Z. Alright, so right now kita kena pecahkan balik the CYZ. So this one is Cx, so this one is Cy, and this one is Cz. Sorry for the sorry for the bad drawing. Alright, so we need to find the Cy and Cz, the potential for Cy and potential for Cz. So at the point, so at this point. Okay, for Cy, wait for K. Alright, right now what we need to do is we need to find out the VYZ first. Oh, sorry, my mistake. Why we need to find the VYZ? Because of VYZ is parallel, Cy and Cz is parallel, so we need to find it first. Alright, so QYZ is equals to CYZ times with the VYZ. So right now we know that QYZ, which is QYZ, which is same word with the QX. Okay, we know that QYZ is equals to the QX and also equals to the QT. Right. So right now QYZ is equals to 2.4 times 10 to the power negative 5 coulomb. Alright. So for this question, so VYZ is equals to QYZ divided by CYZ. Alright, QYZ is 2.4 times 10 to the power negative 5 coulomb, and CYZ is this one 3 microfarad. So we divide it 3 microfarad, and then you get 8 volt. So VYZ is 8 volt. So right now we know that Cy and Cz, the potential is same, which is Vyz, which is 8 volt. So right now we can calculate, we can find the charge at the Cy and charge at the Cz. It's just the same. Alright. So to find the Cy first lah. So Qy is equals to Cy Vy. So because we know that Vy is 8 volt and Cy is 1 microfarad. So Cy is 1 microfarad times with the Vy. Vy is 8 volt. Because Vyz is equals to Vy and also equals to Vz. Right, so Cy we can get the 8 microfarad. Okay, or sorry, not farad, coulomb, or 8 times 10 to the power negative 6 coulomb. So then we find the Q Z Cz times Vz. So Cz is 2 microfarad. Vz is 8 volt, and then can get 1.6 times 10 to the power negative 5 coulomb. Right, so right now we have done find everything. Right, so what we need to do is we need to declare everything that we have found it. So for Cx is equals to 6 microfarad, and Qx is equals to 2.4 times 10 to the power negative 5 coulomb, and Vx is equals to 4 volt. Cy is equals to 1 microfarad, and Qy is equals to 8 times 10 to the power negative 6 coulomb, and Vy is equals to 8 volt. And then Cz is equals to 2 microfarad, and Qz is equals to 1.6 times 10 to the power negative 5 coulomb, and Vz is equals to 8 volt. Oh my god. So right now we have done. Okay. Alright. Okay, so back to the PowerPoint. So we have done. So that's all, folks. So we conclude together our lesson. So let's go. So the capacitor in series is that you need to know the basic thing is the charge and how the charge and how the potential. So if we know the charge, how the charge and how the potential, and then we can find the effective capacitance. So for capacitor in series, the charge Qt, total charge is equals to Q1 is equals to Q2 and equals to Qt. So every charge in capacitor that is connected in series is the same, right? But then for the potential is different. So we need to find the potential total is equals to V1 plus V2 and plus V3. Okay. Right, so next, so after we derive, what we found is to find the C effective, for series circuit is 1 over C effective is equals to 1 over C1 plus 1 over C2 and plus 1 over C3, right? So this question. So next is capacitor in parallel. So the thing that you need to know, which is charge, how about the charge and how about the potential in parallel. So the charge in the parallel is total charge. The charge in the parallel is different for every capacitor. So capacitor 1 have a charge different with the capacitor 2 and also different with the charge at the capacitor 3. It means that total charge is equals to Q1, which is charge at the capacitor 1 plus with the charge 2 and plus with the charge at capacitor 3, and then you can get the charge total. But then for potential is same for every capacitor that is connected in parallel. So VT is equals to V potential at the capacitor 1 and equals to the with the potential at capacitor 2 and also equals with the potential at capacitor 3. So and then we have derived, so we get the effective capacitor formula, which is C effective is equals to C1 plus C2 plus C3, right? So now I think we have done. Oh yeah, right. So when we have this question, this kind of question, what we need to do is first is look into the circuit. Okay, into the circuit. So if the circuit is series or parallel, so to find the C effective, you need to use the circuit punya and you need to use the series punya ataupun the parallel punya formula, right? If combination, right, so if it is a combination, what you need to do is simplify the circuit, right? So if there is a parallel, so simplify the parallel first. Simplify the parallel first, then baru series. Okay, and then it's on you. You can find everything that the question asks you, right? So I think that's all. Thank you everyone. Good luck for your next chapter. Bye bye. I'm SYAHMI. See you again. Mwah.